Hello, welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry here. How are you all? So, welcome to NEET one shot session series. Here we are in hydrocarbons. In the previous class, we completed hydrocarbons session 1, that is a part 1. We are into hydrocarbons part 2. So, please confirm you are all able to hear me. You can see me. Quickly give me a chat response there. Welcome to NEET Infinity Land channel. Very good, wonderful. So expecting Pinkamina is online and many concurrent viewers are there, my dear students. Wonderful. So please confirm so that we can start the session, right? So in this NEET hydrocarbon one shot, what are the topics we are supposed to do in today's class? So before going for that, oath of the day is crack your NEET examination, simply attending our sessions by take a pen and paper and write each and every point and each and every reaction from the NCERT and NEET based things are going to be explained, and take a short note so that one round of revision is going to be completed. For that, attend the live classes and please like, share, subscribe to the Infinity Land channel, and please give any comment. If you have any doubt, use the comment box to write this. And also in the NEET, hi Radha Krishna, I am the best, Infinity Land is the best, my dear. And as your preparation for your NEET examination, simply by clicking the link given below, Infinity Learn app is there. From that Infinity Learn app, you can access live classes, mock test, and create your own test. Any topic, if you have any doubt, you can create your own test based on that particular topic. So that is exclusive for this app users, and it is completely free of cost and 24 by doubt resolution student. So any doubt, anytime, anywhere, your doubt is going to be one click away. And last but not least, when you are preparing some examination, it is required to understand where exactly you stand and how you are doing. And for that required a proper assessment platform, that assessment platform scientifically designed by Infinity Land, NEET 2025 test series. So all India test series, you can benchmark yourself against India's the best coaching institute, Sri Chaitanya, and you are going to have 34 full syllabus test and 14 grand test, 20 mock test. And detailed video solutions are there. Dear students, there is a price drop. It was 6,000, now it is getting for 1,200 rupees, 80% off. Okay, so you can apply your coupon code YT80. If you apply this coupon code now, you are going to get it for this price. And while it, click the link that is given in the pinned messages and the description box. You can do the best. Okay, anyways, let us go. Promo is over and let's go into the details of the subject. And if any doubts are there, you can discuss with me, you can talk to me, and many things to come, topics that you need to discuss in this hydrocarbons, that is alkanes and alkenes and alkynes and arenes. So this is completed in the part 1 beta. It is already completed, and we are going to discuss this alkene and alkyne is in the part 2. And this comes in the part 3. So we are organized these sessions in such a way that you never miss anything, and your NEET examination preparation is going to be super awesome, and you are going to build your confidence levels in the examination. Dear students, for writing NEET examination, always I cater one thing over here. It is not required how depth the subject you know, but how stable you are in a subject and how you are able to understand. In today's class, I can guarantee you that alkenes A to Z, all the reactions are going to be discussed, alkynes also, and also hydrocarbons. Multiple choice questions are also there with us in today's class. So stay tuned. Let us directly talk about alkenes. So the slides are there with alkane, alkene and alkyne, and let us directly jump into the alkene. So if you have any doubt, my dear children, about the alkene, you can ask us. Yeah, this is about alkenes. Ready for that? Alkenes. So Radhe Krishna, come on. Dear children, if you have any doubt about the alkanes, you can ask so that I can revise those reactions for a while. Otherwise, I directly get into the alkanes. So stay connected, and these sessions are quite important, and the teacher is there here from Infinity Land and is going to discuss all the reactions and all the concepts from us. And if you have any doubts, you can use the chat box generously for the academic purpose, and you can discuss with us. So it is a two-way communication system. So students, we are doing the best for the students who are preparing for NEET examination. It is full free of cost, so that you need not have to pay anything. Simply attend our class. Please like sessions and share with your friends. इन लोगों को भी फायदा होना चाहिए. And you can use the chat box for asking doubts. So dear students, here alkenes are the homologous series represented by general formula CnH2n plus 2, right? Here in this the general structure of the alkenes, you can say carbon undergo sp2 hybridization. It is going to be planar system. It is sp2, and you have one sigma bond and one pi bond. So pi bond is so weak. That's the reason why this pi bond is more prone for addition reaction. Okay, it acts as, hi Vedika, hi, how are you? Vedika Art Gallery. Okay, anyways, let us discuss about the methods of preparation, and you have chemical properties and the structure of alkene. You have alkenes. So in that alkenes, you have alkadienes, so you have cumulated dienes and isolated dienes and conjugated dienes, and the chemical reactions of that are going to be discussed. Okay, fine. Let us go into the details about the preparation of alkenes, dehydration of alcohols. What exactly it is happened? Dehydration of alcohols generally carried out either in two ways. One is heating the alcohol with concentrated H2SO4 or H3PO3 to a temperature at 170 degrees centigrade, and it is going to be passing the vapors of alcohols over alumina. It is given in the NCERT, and the temperature is also 350 to 400 degree centigrade. Now you can see this is your alcohol. It is a beta elimination reaction. So alcohol and the hydrogen, and here it is a alpha carbon and this is a beta carbon. So when you do so on either A or B situations, so here what is going to happen? OH is lost and H is lost as H2O. So what happened? There will be a formation of a double bond between this carbon and this carbon, you can say. So this is an alkene. So he need to know various things, how it is done and what it is done. Now ease of dehydration, loss of water molecule is called as a dehydration process. Dear children, most wanted criminal Nandu, I know. Hi Nandu, your name is so nice Nandu, and most wanted criminal, it looks awkward. Okay, anyways, how are you Nandu? How are you doing? Right, so let's talk about these things. When alcohol is treated with any one of the process A or process B, you are going to get an alkene by the loss of water molecule. That's what it is said. And the ease of dehydration, tertiary alcohol is greater than secondary alcohol is greater than primary alcohol. In the NEET examination, you will be asking a question, which of the alcohol is easily dehydrated, or order of dehydration of alcohol is the most expected question for the NEET examination. Nandu, I'm fine, thank you. Right. So this is about the dehydration, and let's do a couple of questions based on. Hi Nagesh. Hello. So as I mentioned, this is a live interactive session. So every student is going to be pitched here, and every academic discussion is going to be pitched. Make use of this discussion. Don't focus on how many users are there and how many chartings are there, not focused there. Academic content is focused over here. Nagesh, come on. Let us talk about dehydration is governed by Saytzeff rule. This is otherwise called Saytzeff rule. That is, greater the number of alkyl groups attached to the double bonded carbon atoms, the more is the stable alkene. So the product formed in the dehydration of alcohol follows Saytzeff rule. Saytzeff rule says during elimination reaction, the product formed is going to be more stable alkene, and during elimination of this, one of the beta hydrogen is eliminated. So I mean to say, if more than one beta hydrogen is there, the carbon, the beta carbon which bears the least number of hydrogen is going to be sacrificed its H plus, so that an alkene is formed accordingly. So that is what is called as Saytzeff rule. So for elimination you use Saytzeff rule, for addition you use Markovnikov rule. My dear students, there are two important rules comes in this alkene chapter. Not only this alkene chapter, it is also linked to alcohol. So as days goes on, as the lessons goes on, so preparation of alkene and the properties of alcohol both are connected. So you are going to have a very concise format of the organic chemistry. Dear children, okay, let us see here. When you talk about CH3, CH2, OH. So what happen if it is H plus? Okay. Now you are going to lose water molecule, so it is going to CH2 and CH2 and H2O. Yes, ethyl alcohol gives rise ethene. Now let's talk about CH3 and CH and OH and CH3. What is the product? You tell me. You require elimination is endothermic process, my dear students. Elimination is endothermic. So what could be the product? Quickly tell me. Yes, what could be the product? Quickly tell me. You can lose this. This is an alpha carbon, this is a beta carbon. You can lose this beta carbon either here. So the product is going to be CH3 and CH double bond CH2. Okay, so that is the product. So let's discuss about one more example. So here we are expected to have a rearrangement also, CH3, CH2 and CH and CH3. Okay, now H plus and here. Now of course this is lost and this is lost, and this is said to be a beta carbon, and this is also said to be a beta carbon, right, Nagesh? So when this is a beta 1 and beta 2, I say beta 1 is eliminated, you are going to get a product like this, CH3 and CH2 and CH double bond CH2. If beta 2 is eliminated, what is the product, my dear children? Here going to be CH3 and CH double bond CH and CH3. Among these two, which is major? But 1 in and but 2 in. So this is a live interactive session, my dear students. Please let me know what is your answer in the comment box. Use the chat box for this. Dear children, come on. What is the answer? Yes, Nagesh. Nando. This is going to be the major, this is going to be the major, and this is going to be the minor. So this is what is called as Saytzeff rule. Why this is Saytzeff rule? So most substituted alkene. So with respect to this, this is substituted. With respect to this, this is substituted. So it is the major. while here you can see this is only the one substitution. So more the number of substitutions, more is going to be the stability by virtue of hyperconjugation. इसमें hyperconjugation का structures 6 structures मिलेगा dear children. Fine. Now here I wanted to say what could be the product. What could be the product? Expecting an answer? Heat it. कोई रुकेगा नहीं. Heat it. Something is written here. I don't understand the name also in different script. Okay, anyways, it is going to be, of course, it is given like this. Dear students, I am going to explain you in hyperconjugation and resonance, stability of carbocations, and very much important things. Here the stability of alkene is directly proportional to, dear children, hyperconjugation. जिस मॉलिक्यूल में, जिस alkene में hyperconjugation ज़्यादा हो, वही alkene ज़्यादा stable होगा. Now let's talk about alkene stability trends. Stability of alkenes increases with increase in substitution. So here this is the alkene ethene. इसका थोड़ा सा हाइड्रोजन हटा के अल्काइल ग्रुप लगा दिया. So because of this substitution, this experiences hyperconjugation. Therefore this is more stable as compared to this. Students, carefully understand. And you can say this is two alkyl groups and this is another alkyl group. So two alkyl groups are there. Dear students, of course trans is going to be more stable than cis because trans experiences less repulsion, cis experiences more repulsion. You understand? While you can say 1,1 geminal, mean to say this is you can say isobutylene. So this I would say, this I would say, this I would say as, so CH3 and C double bond C CH3 and H cis butene is, let us see, CH3 C double bond C CH3 and it is going to be trans butene, and surprisingly you can see CH2 double bond C and CH3 and CH3, this is called isobutylene. Yes, of course, isobutylene is more stable than transbutene, is more stable than cis-butene. This is very important. So hope you're understanding, dear children. Clear? Very good. And you can see tri-substituted and a tetra-substituted. It all depends upon how many methyl groups you have. Number of alpha hydrogen you have to take into the consideration and follow the order of stability based on number of alpha hydrogens and number of hyperconjugation structures. Fine? Clear? That's good. Now most stable, monosubstituted, disubstituted, trisubstituted and tetrasubstituted. Fine? And other factors that stabilizes a strain, it is going to be destabilized. Conjugation is going to be stabilizing factor. And this side is going to be least stable and that side is going to be most stable. Fine? Dear children, here dehydrohalogenation of alkyl halide. What is the meaning of dehydrohalogenation? Now you can see this is your again hydrogen and this is your halogen. Right? Halogen means it is going to be chlorine, bromine and iodine. Usually fluorine is not going to be reacted when it is treated with a base. So what happened? It is going to be beta elimination. So this and this is eliminated, alpha and a beta, and the product is going to be an alkene. You can see this is your alkene. Okay, by means of HX is eliminated, so hydrogen eliminated, halogen is eliminated, that is called as dehydrohalogenation reaction. Dear children, you can see yes, now E is of dehydrohalogenation in the order of tertiary alkyl halide, secondary alkyl halide and primary alkyl halide. So elimination tertiary alkyl halide का ज़्यादा होगा, secondary alkyl halide से. Secondary alkyl halide is more easy to dehydrohalogenate. So ease of dehydrohalogenation of different halogens. Alkyl iodide is more reactive, alkyl bromide is more reactive, alkyl chloride is more reactive, alkyl fluoride कम से कम reactive होगा. Now here is also follow Saytzeff rule. Here is also you have to follow Saytzeff rule. Now you can see CH3 and CH2Cl. When you heat it, potassium hydroxide alcoholic and KOH, you are going to get CH2 double bond CH2 plus HCl. Okay. Now you can see here what could be the product. You can use any basis. Any basis. What are the types of bases we can use? I can tell you that. So you are going to see this is the product and this is the product. So this is a Saytzeff product. This is a Saytzeff product. Are you getting or not? Clear? So what are the base you can use? You can use any base like sodium hydroxide, alcohol, potassium hydroxide, alcohol. Of course, you require heat in every elimination reaction. It is going to be absolutely endothermic process. You can say C2H5ONA and C2H5OH and tertiary butoxide potassium and tertiary butyl alcohol, and this is said to be a bulky base. It is supposed to be a bulky base. Whenever you are using a bulky base, follow Hoffmann product. Whenever bulky base comes, follow Hoffmann product. What is Hoffmann product? You tell me, what is an Hoffmann product? Be confident and improve your confidence levels. There is a long journey to go in preparation of alkenes and alkynes and chemical reactions as well. Let us discuss about the formation of lesser substituted alkene in elimination reaction is also called as Hoffmann elimination, and that of more substituted alkene is called Saytzeff elimination or Saytzeff elimination. Okay, what is that I am going to tell you. So, here super awesome tricks are also available in my class. Let's discuss about this. Let's discuss about this. CH2, CH3 and Br. When you use potassium hydroxide and alcohol and heat it. When you use tertiary butoxide and tertiary butyl alcohol, of course, you need to have heating also. So in these two cases, there are certain magics can happen. What is this? Whenever less bulky bases, 90% of the reactions, okay, are going to be Saytzeff rule, certain reactions are going to follow Hoffmann rule. Now it is going to give you a product here. So bromine is lost. You can eliminate it. This is a beta carbon. So this is a beta 1. Okay, this is also equal to beta 1 only. This is going to be beta 2. If I lose a beta 1, you are going to get a double bond over here. So methyl group will be there. This is going to the major. This is going to be the major. Fine. Fine. What about the next one? Everybody look at this. So it is going to form less substituted alkane. So CH2 double bond like this. So this is going to the major. This is called Saytzeff rule and Saytzeff product. This is what is called as a Saytzeff product. And this is called as Hoffmann product. This is called Hoffmann product. Saytzeff product is also called as Saytzeff product. Okay, is Russian scientist, spelling alag hota hai, same ही चीज है. Okay, so in what cases Hoffmann product is there? That is the $1 million question. In most of the cases you use Saytzeff product, whatever the elimination is going on, use Saytzeff product. In what cases the Hoffmann product is there? So in my class tricks also will be given. Dear students, here use short box for any kind of doubts, so that I am eagerly waiting to see the responses in the chat box so that I can clarify whatever the doubts. Hi Radhakrishna, okay, Vedika and Nandu, come on, and Tribeni Roy is there, Anushka Roy is there in the class. So many students are there, many concurrent viewers are there. Okay, let us talk about the condition for Hoffmann product. Super important point. Condition for Hoffmann product. है ना? So the rule number 1, if the base is bulky, that is the one. Fine. And condition 2, okay, both will not be any one of the condition. If the leaving group is a poor leaving group, if the leaving group is a poor leaving group, you are going to see the Hoffmann product. And also the third one is a thermal decomposition. Thermal decomposition reactions like coop elimination, okay, tertiary ammonium hydroxide eliminations, we are going to see Hoffmann product. So by cracking the questions in the NEET examination, you require these noteworthy points to check which is the correct option for the given question. Ready for that? Any doubt? Okay. So let's see some more things, some more questions also there. Now by dehalogenation of vicinal dihalides. Now 1,2-dibromo, what is vicinal? This is called as a vicinal dihalide. When the halogens are present on the same carbon atom, that is called as a geminal. So what we require here, it is a vicinal. So when vicinal dihalide is treated with zinc metal, and zinc is going to take care of this bromine, so zinc bromide is formed. So going to see CH2 double bond, CH2, are you getting or not? Clear? And also you can see what could be the product, my dear children, here. Quickly tell me, what could be the product you can say? Product, remove zinc bromide. Remove zinc bromide, and there is going to be an alkene over here. Are you getting or not? Clear? Perfect. And you can do any kind of things. Now I wanted to give you very good important thing. Okay, so here electrolysis of aqueous solution of sodium salts of dicarboxylic acid, for ethane you can say. Okay, look at this. CH2, CH2, COOK, potassium succinate. This is a potassium succinate. It is electrolyzed in aqueous solution. So, in aqueous solution means in the presence of water. Carefully you see how this is going to be implemented. OH minus and H plus is a water molecule, and OH minus and H plus water molecule on electrolysis. On electrolysis, carefully you see how this is implemented over here. So, K plus and OH minus is going to give you KOH, K plus and OH minus is going to give you KOH. So, you are going to see 2 KOH as a product. Okay, fine. Now, H plus and H plus taken as H2 gas, it is formed as a cathode. It is formed as a cathode. Okay, dear children. Now, you can see CO2 and CO2, 2 CO2 formed as anode. Now, we are going to see the formation of CH2 and CH2, C2H2, C2H4. It is going to form that anode. So, when question will be asked in the NEET examination, dear children, so what could be the product that is formed when aqueous solution of potassium succinate is electrolyzed? The product formed at anode and the product formed at cathode. So, that is the noteworthy point for NEET examination students. So, don't you fail, right? Come on, quick response. Wonderful. So, never leave this session. So, each and when you wanted to, your already syllabus is completed. We are ahead of joining with an actual NEET examination conducted by NTA. So, you already completed syllabus now, you will revise it. While you are revising this, so when you start alkene or hydrocarbon, it takes 2 days to revise. But in the YouTube session, Suresh sir is discussing each and every reaction with proper logic and proper tricks and tips. So, attending this class gives a super awesome experience without pain and relaxed way. So, this is going to be a golden opportunity. So, we are not expecting nothing from you. Simply attend the class, listen to us and write the equations along with us in this simplified manner, so that you are going to experience super awesome things. Okay, dear children, let's go ahead. So, give one thumbs up and fire emoji in the chat box. Students kept quiet in the session, so I feel also bad. So, I wanted you to please give a thumbs up and fire emoji in the class, so that we can discuss one more equation. So, controlled hydrogenation of alkynes, it is my favorite reaction. It is my favorite reaction. So, what exactly hydrogenation on heterogeneous catalyst? When alkyne is taken, when you add H2 plus PD, so you are going to get an alkane as a product. So, this is what is called as exhaustive hydrogenation. So, in this exhaustive hydrogenation, alkyne gives alkane. So, कोई रुकेगा नहीं, ये reactions आगे बढ़ते जाना alkane तक. Okay, now I just want to discuss about here partial reduction can happen. How this partial reduction can happen? By using either Lindlar's catalyst, or you can use liquid ammonia and sodium metal. So, when alkyne is treated with H2 in the PD in the presence of calcium carbonate, or you can also use lead carbonate. This is called a quinoline as a solvent. This is quinoline. You are going to convert alkyne into alkene. So, the product is going to be stereochemically, it is a cis product, and this is going to be syn addition. This is going to be syn addition. Okay, when you talk about the partial reduction with sodium in liquid ammonia or lithium in liquid ammonia, you are going to get alkyne is going to get an alkene, but it is going to be, in this case it was cis, now it is going to be a transalkene and it is going to be anti-addition. So wanted to say, my dear children, what makes this is a syn addition and anti-addition. Okay, look at this. This is going to be a double bond. Okay, in this double bond, if you are adding something from the same side, okay, this is called syn addition. So this is what is called as a syn addition. Now when you see the double bond, a double bond is given here. Okay, so you are adding something on the other side of here. So this is what is called as an anti-addition. So this is what is called anti-addition. Okay, so this stereochemistry of addition, everybody should have a control on it. Okay, any doubt in this? Please make a note of it. Make it fast. Make it. If you have any doubts, please let us know. So we are not going to skip any single reaction. So every reaction related to NEET examination will be discussed in this class. Fine. Okay, let us go ahead with one more thing, physical properties of alkenes. Okay, so alkenes physical properties just like alkane physical properties. The first three members of the family, ethene, propene, butene, are colorless gases, so C2, C3, C4. And C5 to C15 are liquids, while higher alkenes are solids, except ethene, which has a pleasant smell. Other are colorless, other alkenes are odorless. Okay, wonderful. And the melting points is very important. The melting point of alkenes do not show a regular gradation. Why so? Because they have a cis and trans isomers in that. So you can't generalize that. I am going to show you the best trick to say cis and trans melting point and boiling point. So however, the melting points of alkenes are higher than that of corresponding alkanes. Okay, among the isomer of alkenes, transalkene have higher melting point than corresponding cis isomer. Okay, very important noteworthy point. Even talking about the boiling point, my dear students, the boiling point of alkenes, just like an alkanes, show a regular gradation with increase in the molecular weight. Okay, and the number of carbon atoms. Amongst the alkenes which show geometrical isomerism, cis alkenes will have higher boiling point than the corresponding transalkene isomer, and this is due to the reason that cis alkenes being polar have stronger dipole-dipole interactions. So let's see, this is the general trend. Okay, I want to give you the overall picture about melting point and boiling point among the trans and cis alkenes. Okay, solubility, alkenes are insoluble because the general polar solubilities. Okay, so alkenes, like alkanes being either non-polar or weakly polar molecules, and it is practically insoluble in water. Of course, everybody knows that in the polar solvents, but it is soluble in non-polar solvents and organic solvents. Okay, dear children, if you see density of alkenes is just like an alkenes is always less than water, so that alkenes, alkenes, all hydrocarbon float on the water. Highest is going to be 0.89 gram per cc. Okay, dear children, so thus alkenes are lighter than water, so they float on the water. Are you getting or not? Clear? Now it's an awesome slide I wanted to make you. So here this is a cis alkene and this is a trans alkene. So transalkene opposite dipoles are going to be cancel each other. Rather, you can say dipole moment is going to be 0 dbi, while here it is going to be dipole moment resultant is not 0. It is little polar. Because of the polarity, its intermolecular forces are increased. Whenever intermolecular forces are increased, its boiling point you can say 60 degrees. So as intermolecular force, boiling point depends upon intermolecular force. चाहे इसका intermolecular force London dispersion force हो सकते, van der Waals forces भी हो सकते, dipole forces भी हो सकते, because of the halogen is there. And talking about this melting point is directly proportional to how efficiently these molecules are packed within the molecule. So you can say packing efficiency. So more the symmetrical structure, more will be the packing efficiency, dear students. So that what happens, melting point and is higher for trans because of the symmetrical structure, it is efficiently packed. Understand? So this can be true in this current slide or any part of the organic chemistry or inorganic chemistry or physical science. So you can see, take a snap of this. Intermolecular dipole interactions increases the boiling point. Symmetrical structures have this higher melting point. So this is going to be an awesome slide for you all. If you have any doubts, please let us know. Well, fine, आगे बढ़ते हैं थोड़ा. Now, so chemical properties of alkanes. Alkanes undergo mainly addition reactions. What is this addition reactions? Generally, it is going to be maybe an electrophilic addition reaction, or maybe free radical addition reaction. There are two things you need to know. So, addition reactions are the opposite of the elimination reaction. Now, when you talk about this alkene, when A, B is added, so A, B, A plus and B minus, so you are going to see the formation of A is added, B is added. This is what is called as an addition reaction. Okay. So where A should add, where B should add, it all depends upon the type of electrophile or type of free radical and all. So let's talk about these types of addition reaction. Now addition of HX, yes, HX, reactivity, HI is more reactive than HBr is more reactive than HCl is more reactive than HF. Yes, of course, HF usually we don't make it reacted. Okay. And here a part of the electrophile and the part of the nucleophile should participate in this reaction. So let's discuss about this. So addition of HX, let's see here, CH2 double bond CH2, let us add HCl. So HCl, you are going to see CH3 CH2Cl. Okay. Now what happened here? Carefully see, I just want to give you the mechanism by virtue of its carbocationase intermediate. Now it follows Markovnikov addition. When a molecule of HX adds up the unsymmetrical unsaturated hydrocarbon, the halogen atoms goes to the unsaturated carbon atom being lesser number of hydrogen atom. I just want to say here, my dear children, so the negative part of the reagent attaches to the carbon double bond which bear the least number of hydrogen atoms. That's it. That's it. That gives you a super awesome important example over here. And there is a danger also. I'll tell you, CH3 and CH double bond CH2. When you add HBr, so what could be the fate? That's the deal. So everybody knows the answer, but let me give you how to use this rule in this example. And let me give you where not to use this rule. Very important here. Let's see, CH3 and CH double bond CH2, H plus and Br minus na. So that H plus, it is going to give you a carbocation like this, CH3 and CH2 and CH2 plus, and also you can see CH3 and CH and CH3 plus, right? Now what happened, you know? The rest of the Br minus, na, that is going to be attached here. And the Br minus is going to be attached here. So when Br minus attaches here, so it is carefully going there, it is carefully going there. So as a result of this, you're going to see the formation of CH3, CH2 and CH2 and Br. And you're going to see CH3 and CH and CH3 Br. So this I wanted to say a major, this I wanted to say a minor. On what basis this 2 bromopropane is a major and 1 bromopropane is a minor? So there is a problem in the chart box. It seems students are not using the chart box. Okay, so use this because of this is more stable and this is relatively less stable. This is going to be relatively less stable. As a result of this, more is the stability of the reagent intermediate, major is going to be the product and vice versa. So this is the more stable, so it is going to be a major product, my dear students, and this is going to be the minor product. So the major and the minor is defined what is the actual product, and this is the outcome of the Markovnikov addition or Markovnikov rule. Markovnikov addition or Markovnikov rule. Dear students, whenever carbocation rearranges, don't use Markovnikov directly. That is the alarm I want to give you. Majority of the student miss here. Markovnikov rule is true, yes it is true. Markovnikov rule is true, yes it is true. But it is not directly applicable whenever carbocation is rearranging. So that I want to use this whenever carbocation rearranges, possibly do not use Markovnikov rule directly. So what is this kind of rearrangement? Let me tell you. here so many things I just want to take. Little bit rearrangement products also I wanted to write. So, lot many questions are also getting ready for you. Ready to solve the questions? Ready to solve the questions? Yes, of course. So, where I wanted to go for this rearrangement product, look at this, look at this. So, what could be this? I want you to give the IUPAC name of the product. IUPAC name of the product. So, okay, write down. Next slide I will give you one more question. 2-3 questions will do it. You know? 2-3 questions will do it. So, for the same structure, let me write this is CH3, CH and CH3 and CH double bond CH2, right? So, whenever HBr is added, carefully see, very good number of questions with very good logics and very good mechanisms also. So, directly without mechanism also I can give you, I will give you super awesome trick for that. Okay. So, when H plus is attached, so formation of carbocation is always rate determining step, my dear children. So, look at this, C is going to be CH3 and CH and CH3 and CH plus and CH3. Fine. Now, this is a secondary carbocation, less stable, tertiary carbocation is more stable than secondary carbocation is more stable than primary carbocation. Before tertiary carbocation, you have benzyl carbocation is more stable than tertiary carbocation, allyl carbocation is more stable than tertiary carbocation is more stable than secondary carbocation is more stable than primary carbocation. So, in my class right now, I am continuously discussing the concept where you are going to see a valuable information and a valuable content as well. Fine. So, what I mean to say, the hydrogen present here is going to shift from here to here, that is called 1, 2 hydride shift. This is logically called as 1, 2 hydride shift. So, as a result of this, you are going to see the formation of a tertiary carbocation. So, CH3 and C and CH3 and plus, and it is going to be CH2 and CH3. Okay. Now, this is a tertiary carbocation, logically it is more stable as compared to the secondary carbocation. Therefore, what happens whenever it is attacked with a counter nucleophile Br minus, it is going to be attacked here. Therefore, we will see the product as CH3, C, CH3 and Br and CH2 and CH3. Okay, this is actually the rearranged from more stable carbocation is going to be the major product. It is going to be the major product. Are you getting or not? So, in the examination, you will be given a question like this, answer like this. Okay. So, you may simply apply Markovnikov rule, so that this is going to be the major product as far as the student perception is concerned, but this is the major product as far as the mechanism is concerned. So, try to adapt the mechanistic approach, try to use the mechanistic approach. In the NEET examination, question paper is going to be so simple, so logic, and the question paper drives you in such a way that question paper makes you to go for application oriented questions, not like The question paper is not going to test you how depth your knowledge is, rather it is going to test you how efficiently you are applying for the concept. So that is the extract of the last decade NEET examination analysis. Dear students, fine, we'll give two couple of questions. Ready? Once you are ready, give me thumbs up in the fire emoji in the chat box. Dear children, fine. That's good. One more question. Let us write the mechanism generously and write it. Okay. So इसका product आता है क्या? HCl. Write down. I want you to give the answer. Use the chat box. Give the UPSC name of that. I am ready to give this. My dear children. You can directly use this. And HCl, Hu plus, make a carbocation. So once you make a carbocation, this is your secondary carbocation, and the secondary carbocation can undergo a methyl shift. पिछले एग्जाम्पल में हाइड्रेट शिफ्ट था, अभी ये एग्जाम्पल में मिथाइल शिफ्ट होना चाहिए. Okay, whenever methyl group and hydrogen is there, methyl group is going to be rearranged and shifted. So the leaving ability is important. Weaker bases are going to be better leaving groups, mind it. So you are going to see rearrange from here to here, so that you would get a carbocation here. Now it is going to be Cl minus. So Cl minus attacks here. You are going to see the formation of the product. So rearrangement के हिसाब से बिल्कुल एक क्वेश्चन आ सकता. Are you getting or not? 2-chloro-2,3 dimethyl butane. 2-chloro-2,3 dimethyl butane. Fine. Dear children, we'll discuss one more. What could be the product over here? कभी कभी ring expansion भी हो सकता. Hint is given. Make it fast. Dear children, do it. So don't take anything from your memory and write it. Don't take anything from your mind and write it. Right. So let's see the mechanistic property here. Always use the mechanism like this. Okay. When it is done with H plus, okay, it is going to be a probable carbocation. My dear lovely children. So you are going to see the carbocation like this. So there is a term called Wagner rearrangement where the ring is going to be expanded. This is the pair of electron. This pair of electron is going to be shifted from here to here. So as a result of this, what happens? Carefully you observe. So there was a bond over here, right? There was a bond over here. That is broken. And you are going to establish a new bond over here. Therefore, there is a positive charge. You all understand? You all understand this? Yes, of course. Now this can be also written as 1, 2, 3, 4, 5, 6, right? So it is going to be like this. You can name it. You can name it. You can name it. This is going to be A, B, C, D, E, F, G. Okay. Now this is going to be A, B, C, D, E, F, G. Now you never confuse if you name like this. A का कार्बन कहाँ गए, B का कार्बन कहाँ गए, C का कार्बन कहाँ गया. Okay, you can say this is A and this is B, C, D, E, F, G. Okay, carbon number has to be conserved. Aura King, thank you very much. Bless you. And you can see from here to here it is transformed. This bond यहाँ पर तोड़ के यहाँ लगाना है बस. ठीक है. फिलहाल ये 5 मेंबर रिंग था, अभी 6 मेंबर रिंग बन गया. इसका स्टेरिकल रीजन का हिसाब से ये ज्यादा स्टेबल होता है. बेयर स्ट्रेन थ्योरी. ओके. And in this always 6 membered ring is going to be cyclic, 6 membered ring is going to be stable. Are you getting or not? Now as a result of this, फिलहाल ये 6 membered secondary carbocation. तो क्या करूँ मैं, यहाँ से एक हाइड्रोजन यहाँ बदल के हाइड्रेट शिफ्ट कर दो. हाइड्रेट शिफ्ट करने के बाद मिलेगा आपका 1 to हाइड्रेट शिफ्ट करने के बाद आपका मिलेगा a tertiary carbocation. You see how simple, but students looks this process as complicated. Yeah, this is not at all a complicated process. Final touch up, you can give it I minus है ना, H plus and I minus. ये लगा दो इसको. सो मिलेगा आपका प्रोडक्ट. इतना आसानी काम है. So it is going to be CH3 and I. That is my product, my dear students. Clear? Now, can we go ahead with the anti-Marconic of addition? Come on. Anti-Marconic of addition. Let's talk about addition of HX, anti-Marconic of addition. This is also called as a peroxide effect. This also, hi Abhishek, good afternoon. So what happened? This is very, very important. Okay, CH3, CH double bond CH2. When you add HBr, when you add HBr in the presence of peroxide, so this is going to give you CH3, CHBr and CH3 and CH3, CH2, CH2Br, and here is also you are going to see CH3, CH2 and CH2Br and CH3 and CH and CH3. So let me write the same thing. so that students will understand. Anurag, how are you doing? In this case, may fine, thank Abhishek. This is going to be the major. This is going to be the minor. Why it is major and this is minor? That makes the difference. This is popularly known as peroxide effect. This is called as a peroxide effect. This is also called as a Karaj effect. This is also called as a Karaj effect. And this works, very dangerous thing, works only with, applicable only with HBr only. If you use HCl and peroxide, no effect. Okay, HI peroxide, no effect. HBr peroxide, it has an effect. Now, I wanted to say here, very important thing, this follows electrophilic addition reaction. Where you got a carbocationase intermediate. This follows free radical addition reaction. This follows a free radical addition. Carbon free radical is an intermediate. Carbon free radical is an intermediate. Are you getting or not? It's very, very important. This is called as anti-Markovnikov addition or Karash effect or peroxide effect. You want me to give a mechanism for that, Abhishek? I am ready to give. Or otherwise, you can go ahead with one more question, one more reaction. Ready for that? Mechanism or reaction? Depends on you. As per your request. As per request. Abhishek. How about your preparation? कैसा चल रहा है आपका preparation? आपका mechanism चाहिए? बस मैं देने का तैयार हूँ. Mechanism. Okay, let me give you the mechanism here. Addition of HBr in the presence of peroxide follows anti-Markovnikov addition, and it has a free radical addition mechanism. Let's see. Yes, mechanism. HBr, so CH3, CH double bond, CH2, when you add HBr in the presence of peroxide. So, what is the mechanism? It follows free radical addition mechanism. Abhishek, it is for you. Everybody witness, students who are using the chart box, you are going to get a benefit because Abhishek asked mechanism, I am writing the mechanism, right? Now, let us see what is the mechanism for this. Benzoyl peroxide is taken. This is your benzoyl peroxide. So, this benzoyl peroxide undergo homolysis. When you undergo homolysis, you are going to see the formation of benzoyl free radical. C double bond O, O dot. है ना? So, you got benzoyl free radical. This benzoyl free radical is going to react with HBr Okay, so HBr, now it is going to give you homolysis, and this homolysis gives rise benzoic acid, and Br free radical is generated, right? This Br free radical can attach CH3 C double CH double bond CH when it is treated with the Br free radical. Now it can give you a tertiary free radical, secondary free radical, which is more stable. आपका पता है the stability of this carbocation, stability of the free radical both follows the same methodology, right? So this is a secondary free radical and this is going to be primary free radical. It is going to be more stable. It is going to be more stable. As this undergoing more stable, it is going to give you HBr, okay, and so Br free radical is left and it is going to give you the major product like the CH3, CH, CH2 and CH2Br. So it is going to be the major product. Okay, this happens only in the case of peroxide. In the case of HBr, it is not true in the case HF, HCl, HI. Abhishek, संतुष्ट है बेटा? Ara King, happy? Okay, any doubt? Please let me know. Any doubt? Please let me know. Now, dear students, a short break so that we can have some more important reactions. Okay? So a self timer, I just want to make it quickly. Right. I'll be back in a minute. 2 o'clock. Okay, students, welcome back. So a short break. Now we are in the discussion again. We'll go back to this is about the peroxide effect, free radical addition mechanism. Abhishek, as you asked, I have given you the mechanism as well. So any students, you just follow these mechanisms and get well with where should we, all these NEET examination questions. So go back to the actual discussion where we are. A long way to go. Yes. So rearrangement in HX, already we did it. Rearrangement in HX. So various rearrangements also we did it. So a short recapture about the rearrangements. Here it is going to be HBr. The product is going to be like this. Surprisingly, this is mechanism already we have seen. You all able to hear me? Abhishek, a confirmation dena. Nagesh, Aura King. Very good. Now I wanted to give you what could be the product. Let us write. अरे NEET examination में थोड़ा सा पसीना निकालना पड़ता. If you feel it difficult ना, you are going to get sweat. But you feel it as if you are very, very happy with the equation. So you need to understand. So let me write if H plus and Br minus na, पहले H plus निकाल दो. Oh yes, you got it. You are going to get a carbocation like this. So this carbocation is going to be rearranged to give its make it like this if not. So it is going to be little comfortable. Okay, use the same way. It is shifted from here to here. Now you are going to see. And here a new bond is formed here. You can check it. As a result of this, this is the carbocation, right? Now let's see. You want to have any doubt here? You just say A, B, C, D, E, F, G and H. And it is going to be A, B, C, D, E, F, G and H. Fine? Again, yeah, absolutely. Now it is going to give you the hexagon, okay, and you have this one and this one, and let us renumber it. It is going to be A and it is B, C, D, E, F, D, this is the simplest trick to learn E, F, G H. Where you got a positive charge? Where you got the positive charge? I got the positive charge on the C carbon atom. I got the positive charge on C carbon atom, right? Okay. So this is a secondary carbocation. I have an hydrogen over here. So make this hydrogen shifted from here to here. Make the hydrogen shifted from here to here. Okay. Now you got a tertiary carbocation. This tertiary carbocation, this is your tertiary carbocation. This tertiary carbocation got it Br minus, so attached over there. It is going to be find rearrangements in addition of HX. How depth the journey is going on, my dear students. Okay, now you can relabel it. वही हो जाएगा ना, ठीक है बेटा. Love organic chemistry. Clear? Now, addition of HX in cycloalkanes also follows Markovnikov rule. So it is a methyl cyclohexene. When you add HBr, you are going to get one bromomethyl cyclohexane. Addition of HCl and HI in the presence of peroxide follows Markovnikov rule. So why? Peroxide effect do not work with HCl, do not work with HI. Assertion reasoning type questions in the organic chemistry is very important. Very important, dear students. And also addition of H2O are super important thing. Acid catalyzed addition, acid catalyzed addition of H2O produces alcohols, follows the Markovnikov rule. What is this? Now we can see CH3, CH double bond CH2. If you add dilute H2SO4 and you heat it, I mean to say water. So the what is the product? Let me write this mechanism. It follows electrophilic addition reaction. It follows electrophilic addition reaction. You want me to directly write the product? Or you want me to give the mechanism? Abhishek, decision is yours. You want me to give the mechanism? Okay, I'll give you. So what exactly happened? H2SO4 gives rise H plus HSO4 minus, right? Now you can see CH3 CH double bond CH2. In the presence of acid, H plus a proton is an electrophile is being added. So what happened here? CH3 and CH and CH2 plus. So a probable more stable carbocation is formed. Understand? Now it is going to be added with a water molecule. Water molecule means the lone pair of electron present on the oxygen act as a nucleophile. So the lone pair of electron is being attached over here. Okay, so it is going to give you CH3 and CH and CH2, and you can write it here or you can write it here also. It is going to be OH plus. Got it? Clear? Now this loses a proton. Okay. Now this is lost as a proton, so that you're going to see the formation of CH3, CH and OH and CH3. Okay, propan 1-ol is formed. Got it? Propan 1-ol is formed. And addition of water follows 3 methodologies. Okay, let me write these 3 methodologies. Okay, So let me give you here a question like this. Is an alkene, okay? In this alkene, I can add water molecule in three different methods. Super important slide. Everybody, you all use this method. If you use, okay, dilute H2SO4 and you heat it. If you use BH3 and THF and NaOH and H2O2, and you can use HgCH3COO twice, okay, and H2O NaBH4 in the alkaline medium. So there are three different methods, okay. So this is what is called acid catalyzed hydration, this is acid catalyzed hydration, and this is a hydroboration oxidation. And this is what is called as oxymercuration. And demercuration. Oxymercuration, demercuration. So what exactly the products that I am going to show you to form here? Look at this. I am going to form, this is going to be OH. I am going to form, this is going to be the OH. I am going to form, this is going to be the OH. Three different products that are formed. What are the comments based on this? What is the comments based on this? NEET examination में यही चीज़ इस्तेमाल करो. Simple trick. So जब acid catalyzed hydration होता है ना, इसका आपका आएगा acid catalyzed hydration, carbocation is formed intermediate, rearrangement takes place. So that you can also show a Markovnikov product is formed. Markovnikov product is formed. Simple, इतना complicated reaction का यही है note point. If you use this note point, you can crack the NEET examination. Okay, and here this is a anti-Markovnikov addition. This is a Markovnikov addition. This is going to be the Markovnikov addition where you can say but no rearrangement. But no rearrangement. Everybody take a screenshot of this. Quick, 3, 2, 1. Now in these three methods of addition reactions, one follows Markovnikov, another forms anti-Markovnikovs and Markovnikov, but the only difference is no rearrangement takes place here, Markovnikov product. That is only the difference between 1 and 3. And moving ahead, addition of halogen X2 in CCl4. So what exactly it is? A non-classical carbocation is formed. Look at this. This is an alkene when you add Br2 reactivity, you can say Cl2, it can be Br2, it can be I2. Let us add Br2 in CCl4, the product is going to be, by using non-classical carbocation is same. When I talk about this, the bromine gets polarized when a pi bond is coming and approaching it. Therefore, it is going to be positive and this is going to be negative. So, it is going to be forming a non-classical carbocation over here. Br like this. It is a non-classical carbocation. And this non-classical carbocation, cyclobrominium ion, mind it, the name is important. Cyclobrominium ion. So, the cyclohalogenation ion or brominium ion is a non-classical carbocation. Right? Now, it is going to be Br minus cannot attack on the front side, rather it is going to attack on the rear side of this. So, this is an anti-addition reaction. It is going to be anti-addition reaction. So, it is going to be so this is what we say. So, Br2 in CCl4 is actually a red in color. During this reaction, the red color is decolorized. So, it is going to be a test for unsaturation. Test for unsaturation. Are you getting or not? Clear? So, this is an anti-addition. Anti-addition. Clear? Now, let us see the stereo. This reaction is the stereospecific. And I want to say here, whenever you want to see a structure like this, when you add Br2 and CCl4, as I mentioned, it is anti, you are going to get the product like this, you are going to get the product like this. So, Br and Br, so that is the meaning of this. Clear? Abhishek, fine. Now, let us see stereochemistry of halogenation. Yes, it is an anti-addition. It is an anti-addition, just we learned it. Whenever it is undergoing an anti-addition, let us discuss what a cis alkene can give and what a trans alkene can give. So, I just want to say ATM and CAR, ATM and CAR, simple now. What is ATM and what is CAR? Anti-addition on transalkene gives meso product. While Abhishek, cis alkene on anti-addition gives racemic mixture. So that is the mantra for this, right? So let me give you a simple example for that. So anti-addition and transalkene gives meso product. So let us talk about the transalkene CH3. So this is your transalkene and it is going to be CH3 cis alkene. So it's a cis and it is going to be trans. So if you add Br2 and CCl4, if you add Br2 and CCl4, what is the products? Carefully you see. So Br2 CCl4, you are going to see CH3 and CH3 and Br and Br, right? Now it is going to be CH3 and CH3 and Br and Br, and it is going to be CH3 and it is going to be CH3 and it is going to be Br and Br. So this is you going to be a meso product. Children, this is going to be a meso product because you are having a plane of symmetry. Because you have plane of symmetry. You are going to see the mirror image, you are going to see the mirror image and it is going to be a racemic mixture. You are going to see the racemic mixture. Are you getting or not? Clear? That's good. So the magic ATM and CAR, cis alkene on anti-addition gives rise racemic mixture and anti-addition to transalkene gives meso product. That makes the difference. Okay, that is the stereochemistry of this. Okay, let's see one more thing here. Addition of halogen aqueous solutions, what happened? In aqueous solutions, when halogens are added in the presence of aqueous solutions, you are going to get halohydrants. What actually happens? So, X2 react with water, you are going to get HOX. HOX. Like Cl2 react with water, gives rise HOCl. So now it is going to be in halohydrin. Now we can see CH3, CH, CH2. When you add HOCl, you are going to see Marconic of product CH3, CH, CH2 and OH and Cl. Okay, this is what is called as a chlorohydrin, bromohydrin, halohydrin. Are you getting or not? Now, I want you to give the answer for this question, dear children. The product is going to be quickly Cl2 H2O, mean to say it is going to be HOCl plus and minus, है ना? So follow Markovnikov rule, negative part of this is going to be attached to the carbon with the least number of hydrogen atoms, so that you are going to see the product as CH3, here is going to be OH and here going to be Cl. It is of course anti-addition. It is an anti-addition, understand? Clear? Right? Now, hydroxylation is very, very important reaction, my dear students. Hi, Jay boss, Abhishek. So, I'm waiting for your doubts. Jay boss, come on. So, hydroxylation. So, hydroxylation, you can see CH2 double bond CH2. When you add KMNO4 in the alkaline medium in the cold conditions. Don't use hot condition, it is going to be super strong oxidizing agent. You are going to see CH2 and CH2 and it is going to be OH and it is going to be OH. You understand? Clear? So this is called as ethylene and this is ethylene or ethene. It is called as ethylene glycol. It is called as ethylene glycol. This process is called as hydroxylation process. And what are the reagents you can use? You can use OSO4, osmium tetroxide, and NaHSO3 aqueous. Or also you can use KMNO4 in alkaline medium in the cold condition. So what I mean to say, this is also called as a Bayer's reagent. So in this Bayer's reagent, you can see pink color of this Bayer's reagent is going to be decolorized, which is actually pink in color. So the pink color is going to be decolorized. It's going to be colorless. So this is the test for unsaturation. So what are the tests? What are the tests you can go for this? Pink color decolorizes, this is the Bayer's test for alkene, and bromine red color is disappeared, that is also a test for alkene. Any alkene and alkyne can give the test, but benzene do not give this, okay, because of this delocalization. And also cyclopropane can give this test because of the high ring strain. Understand? Now let's talk about it is a syn addition. Of course, both chemistry of this is going to be same. It is going to be syn hydroxylation. Okay, if it is peracid followed by hydrolysis, it is going to be trans-diol is going to be formed. Okay, I wanted to say very, very important thing. Carefully you see. KMNO4 alkaline medium and it is in the cold condition. If it is treated with OSO4 treated with NaHSO3 in aqueous, okay. So if it is treated with MCPBA, metachloroperoxybenzoic acid, followed by acidic hydrolysis, what are the products? And the product that are formed here is going to be the same, here going to be the same. So you are going to see the formation of OH over here, OH over here. It is a syn addition. It is a syn addition, mind it. And you are going to see the product formed is going to be here OH over here and OH over here. It is going to be a trans. It is going to be a trans. Understand? Any doubt, you please let me know. Now, oxidation of alkanes by KMNO for an acidic medium. In the previous case, you can see it is in the alkaline medium. Now we are in acidic medium. So whenever you are treated with the alkaline medium or acidic medium, alkaline medium glycol is formed, whereas in the case of acidic medium, you are going to have a complete oxidation of carbon to carbon double bond takes place. When ethylene is used or ethene is used, this bond is completely broken. This bond is completely broken and you are going to be completely oxidized, and it forms this part formic acid and this part formic acid. The formic acid is initially formed is going to be oxidized to give rise carbon dioxide. When you talk about this, wherever double bond is there, there you are going to break it. This is going to be carbon dioxide, this is going to be carboxylic acid. Whereas you are going to break this, you are going to be a carboxylic acid like this. Simple, it is as simple as it is possible. Now, carefully you see, dear children, you can see here, whenever it is treated with KMNO4 in the alkaline medium, whenever it is treated to be KMNO4 in the acidic medium. In the acidic medium, in the alkaline medium makes the difference between these two. If you know this, you can crack a very good number of questions in the NEET examination. Now we are going to see nothing will happen to this carbon ring and CH3, you are going to make it OH, you are going to make it OH. Of course, that is a syn addition. Of course, that is a syn addition. J Bose. And whenever it is an alkaline acidic medium, you are going to break this, and the product that is going to be, look at this, CH3 and it is going to be COOH, and this is going to be ketone. Are you getting or not? In the NEET examination, you will be asked a question. Okay, what could be the product that can be formed? Okay. Yeah. NEET examination. Okay. So there is a compound X, it is on treatment with KMnO4 and H plus. You got 1 mole of this, okay. So it is going to give you CH3 COOH, okay, and it is going to be CH3 C double bond O, CH2 C double bond O and CH3. Now tell me the structure of the X. So like that, questions are very important for the NEET examination. So simply join this, you add these two molecules here, so that what happens, you know, CH3 C and CH2 and it is C and it is going to be CH3, right? And you simply add double bond C H and CH3 and double bond C H and CH3. So the IUPAC name of this is going to be 1, 2, 3, 4, 5, 6, 7. So 3, 5 dimethyl hept 2, 5 diene. Okay. Sheetal, you will get a notes after this. In the Telegram channel, this notes is going to be transformed into the PDF form and it will be given to that. Sheetal, hope you are understanding the class, and do you feel this class is so much helpful to you? Abhishek? Thank you. Yes, of course. Now, ozonolysis. You have two types of ozonolysis process. One is an oxidative ozonolysis and a reductive ozonolysis. Now, let us talk about R, C, H, double bond CH and R dash. When ozone is added, you are going to get a monoxide followed by ozonide. Followed by ozonide. So whenever alkene treated with ozone, it is going to form monoxide followed by ozonide. So that double bond is lost. So you're going to see C and R dash. It is in a cyclic ozonide. Now it is going to be hydrolyzed in the presence of zinc. Zinc is a reducing agent which prevents the further oxidation of carbonyl over there. Now it is going to be removed as H2O2. So it is going to form a bond over here, a bond over here. Okay. R, C, double bond O, H and R dash C double bond OH. So you got an aldehyde. So if you don't use zinc now, it is going to be reduced. If you use zinc and H2O, it is called as reductive ozonolysis or lithium aluminum hydride and H2O. You are going to get a reductive ozonolysis. If you use H2O2 and acetic acid, you are going to see oxidative ozonolysis. it is going to be oxidative ozonolysis, right? So in the NEET examination, what could be the questions that can be asked? Let me give you an example over here. CH3, CH3, double bond CH and CH3 and H2O2. Okay, so let us make it O3. Zinc and H2O2. Okay. Now you simply break this and make an oxygen. Simply break this and make an oxygen over here and here. That's it. So the product is going to be CH3, C double bond O and CH3 and CH3 and CHO. So where you got this oxygen, for your reference, you can just check the oxygen is coming from. Yes. Got it? Clear? Clear? Now let us use a question. Look at this. What could be the product of this? What could be the product of this? Carefully, you just simply say. And what could be the product of this? What could be the product of this? Very good. Sheetal, explain me. So whenever you are breaking this, you are going to get 2 moles of the acetone, right? 2 moles of the acetone. Here, when you break this, na, CHO, are you getting or not? Are you getting or not? Now, let us say a simple question. Here I got it. Carefully see. An alkene on ozonolysis gives, okay, one mole of alkene, okay, 1 mole of glyoxal and 1 mole of acetaldehyde and 1 mole of acetone. Predict the structure of alkene. How many of you can give? Give the IUPAC name. Sheetal. So this is the analytical oriented questions that are very much required for solving NEET kind of examinations. Okay. So no worries. What is a glyoxal? Glyoxal means CH double bond O, CH double bond O. So 1 mole of acetaldehyde. So that is CH3 C double bond OH, and acetone means CH3, C double bond O, CH3. So what happened? When you go for this ozonolysis reaction, cut the bond and remove the oxygen. The simple trick, remove the oxygen, make the double bond. So I just want to remove this. Make the bond here. I just want to get CH double bond, CH double bond. Now it is going to be CH3. It is going to be CH3 and CH3. What is the IUPAC name of this? So the IUPAC name of this is going to be 1, 2, 3, 4, 5, 6. 2-methyl hex 2, 4 diene. Got it? Diene, Karim, diene, right? Just a small correction in your IUPAC name. What you did is correct. Okay. Anyways, we did very good stuff in today's class, and all alkane and alkene reactions are discussed in this. So diene, 4 diene. It is 2, 4 diene. Clear? Okay. Anyways, we'll meet with more kind of stuff like this, and the marathon sessions are ahead. And please like our session, share with your friends, and subscribe to Infinity Lane NEET YouTube channel. And in the Telegram channel, the entire class notes is going to be given in the PDF form, and everybody join there and you'll get it. Hope you love this session, and thank you very much. Thank you. All the best. God bless you. So we'll meet with more stuff in the haloalkane, haloarenes, and arene topic is also left. So maybe in the day after tomorrow we'll see that. Okay. See you. Bye bye. Signing off. Suresh, Faculty of Chemistry from Infinity Lane. Thank you very much.